We're just waiting for everybody to trickle in, and then we'll get started in a couple minutes.
As Abdullah just said, we're here with our speaker, Mr. Iorio, and we're just going to wait for everyone to join. We have, I think, roughly 30 people here, so I think we're waiting just on a couple more people. So we'll start in our minute. So we'll start around like 2:12. We'll just give it one more minute, and everyone will start filtering in. I think most people are in the call now, so we should be good.
Sounds good.
Okay, since it's 2:12, I think we'll get started now. Yeah, the presentation is as well. It's starting a little late in itself, so I think everyone is in. If not, we'll just wait for them to come on. So, everyone, I would love for you guys to show some love and put your hands together for Mr. Iorio, who is the CEO and co-founder of Augmenta AI, and they're really big in the innovation space using AI. And I think he would love to explain more about Augmenta AI and his role in it. So, I don't want to take up too much time, and I'm excited. I can speak for all of us, I think, when I say that we're super excited to hear your presentation. So without further ado, let's hear it. Thank you so much.
Thank you. Thank you for having me. Okay, let me quickly present my screen. So let me know when you can see what's on my screen. Okay, let me just make sure that this works. Does it work? Actually, can you see my screen?
Yeah, we can see your screen.
Okay, great. So, okay, well, thanks again for having me. It's a pleasure to talk to all of you. Let's say I wanted to talk about a little bit of, let's say, more bleeding edge problems that are being solved with AI, right? So some opportunities and challenges, but mostly opportunities, right? So hopefully this gives you a perspective of what computational science and artificial intelligence is being used at the bleeding edge actually today, what applications, outside of what you may have heard, generally. Right? So just very quickly about myself. So I started actually my career making video games. So back when games actually looked like this. So I'm old. So I started a games developer. So I always liked the opportunity and the challenges to really use the hardware actually as much as possible. So to actually use every means of calculation possible, right? And especially using multiple processors together to actually make computation actually go really fast. We'll see later actually why this is important, right? So, and then eventually I went through university. I got a master's in CS, PhD in computer science as well, right? So, and I actually started actually working for companies like these actually, where I used really large computers to analyze and understand complex problems. Right? So, for example, modeling how oceans actually move around, or how earthquakes propagate, or how they start, or the effects of humans actually on the environment, like hydraulic fracturing for oil extraction. Right? So, and computers like these are actually needed for analysis and simulation of really complex events. Right? So, but more recently, again, the trend is being subverted by modern artificial intelligence methods, and we'll see what it means. Okay, so, at the very least, actually, working with these types of machines that can give a good understanding of what you can do when you have enough computational power to solve really, really complex problems. Then eventually, I actually hit upon one of these things. I don't know if you've ever seen, but I'm sure you're familiar with what a 3D printer is. Right? So this was actually 15 years ago when I first saw at a conference a multi-material 3D printer. So you can imagine 3D printer where instead of actually printing all your objects into one material, you can actually put any material, or let's say combinations of materials and colors, right, so into making what you want. Right? So it dawned on me actually pretty quickly that this level of freedom, so where you can put any material wherever you want in a volume, like in space, right? So I didn't have enough intuition on where to put what in order to solve some, regular engineering problems, right? So like a helmet like that, right? So you can put any material you want wherever you want. What shape should you make the helmet, and where do you put what material, right? So that actually is kind of very quickly actually came back to me that we're not phenomenally well equipped as humans actually to solve these kind of extremely multivariate complex problems, right? So I started actually thinking about it from a computer science perspective, right? Using computational thinking, right? So and trying to think about kind of how computers can help to solve problems of this kind, right? So especially because we need to mitigate our biases. Like, what are the biases? So these are the biases. So when people attack problems, they think about it in some specific ways that tend to limit their ability to get to a particular good design, right? This is, let's say, a traditional path that a problem solver engineer actually would take, to go from a starting point all the way to a final design. And there are many effects, many kind of human cognition biases that affect our behavior, right? So anchoring effect, for example, is the tendency of people to believe that the first thing you pick is correct, right? So, or is actually good, right? So or is the right choice, right? So, or authority bias, right? So, which means that people tend to follow other people's decision that come from a perceived level of authority, right? So more so than actually kind of thinking themselves. So, and then there's this so-called effect heuristics, right? So where we decide with our guts, if you will, right? So and we kind of overestimate the reward, essentially. We overestimate actually the opportunity, right? So and we kind of tend to stick again to the first impressions that we have of a problem, right? So and then the last one is so-called confirmation bias, which is the inclination to choose things that actually confirm our beliefs, right? So that's kind of reinforce what our feelings are, right? So this is a collection of reasons for which the level of complexity of problems that human race actually faces nowadays are really hard, right? So and the challenge is that the tools and the techniques, if you will, that have kind of powered science actually up until now may not be sufficient actually to propel us to the next centuries, if you will, right? So trial and error intuition actually may be a fallacy actually to solve global climate problems, for example. So, but enter computational thinking and AI, right? So modern AI especially. So the interesting thing is that the level of computation that is available nowadays, unlike when I started doing computer programming, so that was a long time ago, right? So we can change the way we can really approach and solve these challenges, and really consider artificial intelligence and computational methods as partners in tackling these challenges, right? So in this scenario, people, people, right? So are there to shepherd the computational methods, shepherd AI by conversing about the problems they're trying to solve and giving the fundamental context for the problems they're trying to solve instead of the solution, right? So, and then you work symbiotically with computer systems, with artificial intelligence, to explore a vast space of possible solutions, right? So this again reduces the bias, right? So it reduces the bias and allows us, with the help of computers and with the help of artificial intelligence, to really think about the trade-offs of the problems that we're trying to solve and really find solutions that normally would be counterintuitive, right? So we'll see some of them actually later, right? So this is a new methodology, effective, right? So where computers have been used as a glorified drawing boards for now. I don't know if any of you actually knows the concept of computer-aided design, CAD, right? So it is actually a glorified electronic drawing board, right? So whereas these new generation of tools that are based on artificial intelligence really participate, together with us in solving these design problems. But like seriously, how all of this actually works? I mean, is it science fiction? It's not. It's not science fiction actually. So this is the bleeding edge. but by all means, actually, these things are actually being used today. So, and this is really kind of what it looks like. Right? So there are kind of four fundamental aspects where AI is being applied to these types of new kind of decision-making and design and solution generation systems, right? So there's a fundamental piece that is the interface with the people, right? So which is the kind of the left side, right? So natural language processing and automated reasoning are used to understand, for essentially to help the computer to understand the problems that we're trying to solve, right? So the problem formulation, the context behind, right? So then for solution generation, to attack a particular problem, like the one I mentioned before, what shape a helmet should have, right? So to actually be as lightweight as possible and to be as protective as possible, for example. So we can use a variety of techniques. Reinforcement learning actually is one where agents kind of learn by trial and error themselves, right? So to solve specific problems. But unlike humans, right? So we can train millions of them, right? So on so-called training sets or gyms, right? So to solve problems that can be fairly complex and that can scale really well. Or GANs or generative adversarial networks. So these are machine learning models that actually produce output, like it can generate new output, right? So that it goes between other outputs or other solutions that have existed before. So, and then in the solution analysis, so these are the eyes of the computer, how a solution that the computer makes up is judged to be good or not very good. Right? So generally, again, engineers actually and scientists use simulation. Right? So simulation is the ability of computer systems to embody large mathematical formulae or large mathematical models to understand how well something performs, right? So how strong something is, how lightweight, how flexible, how well it conduces electricity, and so many other things, right? So, and AI is actually being used in there too, as in simulation is very expensive from a perspective of computation. As I showed you before, it takes enormous computers to simulate complex environments, right? So, but actually with the use of surrogate modeling, which is again another way of using machine learning models to approximate these physics problems, for example. So people can get to solutions and optimize solutions much faster nowadays than it was possible, up until even 10 years ago. So this is an amazing opportunity. And then back to the human side, the visualization of the solutions. So again, a helmet design that the computer makes, or 1,000 helmet designs that the computer makes. Right? So how do we know it's good, or how do we know which one makes more sense than another? Right? So AI actually can be used, for explanation, for example, for clustering, for essentially kind of bringing together, groups of solutions that actually have something in common, right? So in terms of shape, in terms of performance, right, etc. So all these phases, all these four, kind of fundamental phases of this type of workflow are just as important, right? So, and they all can benefit and stand to benefit greatly from applications of AI. So ultimately, again, this is how I consider it, right? So this is, it's a search engine that for things that don't exist. If you think about, what Google is, right? So Google is a way to make sense, right, and search through kind of everything that has already existed, right, that has happened kind of in the past, right? So whereas these types of new systems actually are really, if you will, search engines for stuff that actually has not been discovered yet, right? So for things that actually don't exist yet, right? So if you think about it again, the AI can analyze what happened in the past, and then intuition and computational methods and human input can extend what an AI has seen with new data that has not existed before. Right? So and new algorithms can actually also create new solutions. The AI learns from them also and then keeps expanding. Right? So essentially, every new solution, every new piece of knowledge, right, so it can be reused to expand the domain that the AI can actually reach, see, and then interpolate against. Right? And these are the few things actually that are being made by these types of systems, right? So like a few years ago, the top left corner, actually NASA made an antenna. This is an RF antenna that is mounted on a satellite, right? So, and honestly, without a computer algorithm or artificial intelligence, people would not have designed an antenna that looks like that. And that's the whole point, right? So these types of systems allow us to explore opportunities and designs that have never existed, that we as people would not have done because we've never seen them and we don't know that they're good. So, or some of these systems are used to design molecules, right? So that's a specific antigen that is designed to, at least ideally, to stave off COVID-19 or a particular variant of COVID-19. Or top right in architecture, AI can design neighborhoods layouts, right, for architecture and construction that minimize the waste of energy, or that minimize the waste of water, so for example, right, so, or maximize solar exposure, etc. Right? So much more proactively than what we can do as people ourselves. So, or the bottom left is a lander for a probe that was sent to one of Jupiter's moons, Europa, right? So that design is not conventional. If you look at it actually, or you look at the motorcycle to the bottom right, so it's just not something that we would normally come up with, right? So, but according to physics and according to the artificial intelligence that looked at the physical properties of metal in this case, right? So the AI thinks that it's better than what we come up with, right? So, or we ourselves, right? So just by ourselves. So I just want to give you this message, right? So that AI and computational thinking in general are really instrumental for for the human race, in my opinion, to tackle the type of challenges, enormous challenges that we're facing, right? So again, climate change foremost. So the field, like the science behind it, not just the fundamental research in AI, but the application of AI, right? So to tasks that are not recommending the next product that people should buy, right? So or kind of matching people on a social graph, right? So this type of use of AI actually is, in my opinion, really essential for the actual moving forward of the human race, right? So, and literally there's a little bit for everyone, right? So like anyone actually interested in STEM or scientific disciplines in general, right? So that there's a plethora of problems that this field actually stands to benefit from, from again human-computer interaction to simulation to again computational methods in general, right? Recognition, classification, etc. Right? So I hope that your generation can soon actually become interested and help the scientific community in developing these types of systems. So that's all I had for today.
Let's all show him some love. Thank you so much, Mr. Iorio. That was actually a fantastic presentation. Some really, really interesting new topics that I don't think many of us have actually thought of before this presentation. So it's really gets us thinking about innovation and where the future is going and how important AI really is to our generation.
Indeed.
No, so I guess, sorry?
Thank you for listening. Thank you for
listening. I guess now we have, as we just said in the chat, we have a small question period. So for any of you who have any questions, anything about the presentation or about AI in general, feel free to unmute your mic or even type them up in the chat and ask these questions. But I will read out some of the comments that we're getting. So we're saying, very nice presentation, great presentation. That was awesome. So we have lots of people showing some support in the chat, but anybody with any questions, please do feel free to ask. Now's your chance.
Yeah, so I just wanted to say, first of all, awesome presentation. I really liked it.
Thanks.
I just had a question about the company as well. So how long has it been since you founded the company again?
Oh, yeah. So Augmenta is, again, I didn't mean to talk specifically about the company in here. It's more of an open-ended, right? So, but yeah, the company is 2.5 years old, give or take, right? So before I founded the company, I was a director at this software multinational called Autodesk, right? So, and I actually developed a lot actually of technology for so-called generative design there, right? So, but then the company being a massive corporation has many agendas, right? So, and so I didn't feel like it was moving fast enough actually on the opportunity, and so a group of us left and started Augmenta. So.
Yeah, definitely. So what would you say is like your advice to anyone who's starting a company? Like, finding initial users, the engine of growth, like what would you recommend from that side of things?
Well, I mean, so there's I think one of the classic dilemmas, right? So is follow the problem or follow the solution, right? So the fallacy usually is to find a solution for a problem that doesn't exist, right? So as was discussed earlier, right? But it is also true that sometimes technology can and discoveries in technology can offer avenues to solve problems that we didn't know exist, or that we didn't know existed in the form that is presented, with this new technology being present, right? So when this technology called CRISPR, for example, was invented, right? So to modify genetic sequences, right? So before then, actually, it was effectively impossible to actually do it, very, very quickly or effectively or cheaply. Whereas now, there's almost too much that people can do with it, right? So there's a whole new generation of problems because of that. But in terms of like from a business perspective, if you will, right? So I think that again, certainly finding a good niche, like a good specific problem that applied technology can be crucial, right? So in solving actually is obviously where I would recommend people to start, right? So, but again, don't limit yourselves only at the problems that exist today, right? So that are very, very visible today, right? So again, sometimes again at the cost of again introducing premature solutions, sometimes the most disruptive problems, if you will, are solved by finding the solution, finding a method to tackle them first, right? So and in this case, again, the problem and the solution actually came almost at once, right? So the freedom to solve a particular problem brought more problems. And so the solution was to essentially be there with a solution before the problem got out of hand, essentially. Or so that, I don't know if this helps, but
Yeah, that's awesome advice. Thanks.
I don't think we seem to have any other questions.
yeah, sorry if I
Yeah.
scared everyone off. Like,
Yeah, seems to be no other questions. Everyone's just left speechless, I guess. So if you do have any other questions, do feel free to leave them in the Discord, and we can try to answer them as best as we can. But with that, I would like to thank you very much, Mr. Iorio, for coming out and giving your presentation today. I think I speak on behalf of all of us when I say that we all learned a lot and we can all take away from that presentation. So if everyone, we could slowly start leaving the Google Meet and heading back to the Discord to continue with the rest of our event. And that's about it.